In case you wanted a couple more examples of hypothesis testing, I'm going to give us videos for the next two exercises in 6.4. And you guys will have to tell me whether or not me being down in this corner over here is at all useful, because I don't know, it's kind of creepy. But at least now I give you a tour of a new space, which is my kitchen. So let's go and do this example of hypothesis testing. So as we read through here, we can see, and again, you should probably try this on your own first and then come and watch the video if you had trouble. 69% of the general population belong to a religious community based on some article. So this is going to be our proposed value. Not only does it say the word population, so we're saying that that's what the real value is, but it's from an article, it's a report, so we're probably going to be testing that. And then we get our evidence. In a survey on internet use, 378 of 512 religion surfers seeking spiritual help online belong to a religious community. Is there convincing evidence that the proportion of religious surfers who belong to a religious community is different from the general population? So we also have our keyword in terms of a direction or lack thereof, which is different. So we're going to set up the hypotheses. Our initial hypothesis is that the true proportion of the general population, or of the internet surfers who belong to a religious community, is just equal to the same thing as those in the general population who belong to a religious community. So we're kind of making this assumption that the article value is right in the first place. A little bit of a stretch. And then our alternative hypothesis, well, we just want to show it's different. We don't have any horse in this race in terms of whether it's greater than or less than. Though if we wanted to look at our evidence and sort of see what it's leading us to believe, which is not how you're supposed to do science, by the way. Science, we should have a hypothesis before we go collect data. So if we didn't have a direction in mind before, we can't let the data tell us which direction we're looking at. But we could figure out that 378 of the 512, well, that's 73.83%. So p hat here is 0.7383, which is different than 69, and we just are going to see exactly how different. Now, again, if you want to think visually about what we're doing in this question, we're going to assume that the real value is 69. We got out 0.7383. So we want to say, what's the probability of being here? But since we have this different idea, that means this is the same as being exactly the same amount below 69%. So we have to add those two different tails together in our two-tailed test. So if you're doing this by hand, if you're somebody who's using the 36x in the table, as soon as you write down this not equal to, you should go ahead and put it 2 times in your p-value area. Now, if you're using the calculator shortcuts, it will multiply your p-value by 2, so you don't need to do that. So the next step is calculating our test statistic. So if you're doing this by hand, p hat minus p naught, how different are those two? And how different are they with respect to our hypothesized standard deviation? So how far is 73.83 from 0.69? If 0.69 is really the value, and we can use it for our standard deviation. 512. All right. Now, you guys know me. I would probably just use one prop z test. Just for funds for this one, I'll go ahead and do this the long way and using the shortcut. So if I'm doing this the long way, I'd probably figure out my numerator and then divide by the square root, and I would do this inside of my calculator. I've noticed a lot of the people who are doing this in steps, a lot of times what students like to do, so this is 0.236 or 2.36, is what students like to do is instead to actually do the numerator and the denominator separately. And the issue is if we're going for 4 decimal places, or in this case 2 decimal places in the end, we're dividing by, oops, that's wrong. Let me bring that back. Let me try again to bring that back and correct it. Divided by 512. If you do this in 2 little steps, so this is 0.0204, what can happen sometimes, especially if that 5th decimal is something close to 5, is that if we were to do this in two different stages, you kind of think of the numerator and the denominator separately. So we'd have 0.0483 on the top. And you were to do this, 483 divided by 0.0204. In this case, we would actually round this and get 2.37. So you're getting at a different test statistic and then a different p-value than everyone else. So that would result in you losing points. So you definitely don't want to do those sort of interim steps when you're working on this. You want to make sure that you work through this kind of with more decimal places. So if you do want to do it in stages, keep more than 4 decimal places, because you're going to have rounding errors on that, especially with that denominator, since it's such a small number. So once we get that, we could go ahead and look this up in our table. Now remember, for our table, we don't want to use the bottom half of it because we want tail probabilities. So we're going to look up negative 2.36. So 0.0091 is our value. Oh my God, I always forget to do that. I've already forgotten. See, this is so sad. 0.0091. I refuse to go back. I'm going to trust that that's correct. And if we did this times 2 at the beginning, we're not going to get in any trouble. 0.0182 is our value. And I'll just quickly do this with the calculator shortcut to verify all of this. We were looking at 0.69 being the real value, and we had 378 of 512 people for a two-tailed test. So our z-score should have been 2.36, just like we got, and a p-value of 0.0182. This is one time that our table and our calculator lined up. So, perfect. Now, normally here's where we do our, compare this to our alpha level and then make our statistical decision. And they've gone ahead and changed this, or we've gone ahead and changed this to a multiple choice question. So which of the following would be a correct decision? And it basically says different levels and whether we'd fail to reject or reject. So since we have our p-value, it makes the most sense to just go ahead and do step 4 for all of these different given alphas, right? So they've given us 4 different significant levels, 0.01, 0.05, 0.02, and 0.10. We've got greater, that's less, that's less, that's less. So for this one, we would fail to reject the null, which is not what it says. Here we would reject the null because the p-value is low, which is not what it says. Here we would reject the null, which is what it says. Hooray! And then again, we would reject the null, which is not what it says. So nothing really different except for we had to do the same step 4 times. So that's it. That's this example.